Hi, I'm Mike Ballou from Keysight Technologies, and I'm here at IMS 2024 in Washington, D.C. Keysight is here showing a lot of innovative products, and the one I'm here to talk about today is our phased array test solution, which includes an anechoic chamber, and we have a 256 element phased array that we're evaluating today here on the test floor. And I'm going to show you our software solution that we have that controls the phased array, our F9652 anechoic chamber compact antenna test range, as well as our VNA, the PNAX, the VXGC, and our Pac-Man test software. What we're going to show now is the Keysight phased array antenna control and calibration software. And the first thing that this device will do is controls the phased array that we saw in the chamber. And we'll check the status of the phased array. And you can see all the green elements of the 256 element array are working, except there's two beamformers here that are not responding. So you can quickly identify the health of your device under test. We can also see the temperature of each element of the array using the embedded temperature sensors in the phased array. For phased array measurements, it's important to do a calibration of the array. And in this shot, we can see the yellow trace, which is the phased array before it's calibrated. And our unique solution for calibration is called direct element calibration, where we measure each element of the array, set that one element as a reference. In this case here, number 117 is our reference, and then we normalize all the other elements to the phase of that one element. And you can see in the green trace, after the calibration, the phase response is much flatter across every element of the array, the 256 elements. After we do a calibration, we can then move on and do actual system measurements of that array. So in this case here, we're showing the scan loss profile of that array, where we have 7 beams from the array that we're characterizing the antenna pattern for each of those elements of the array. And we can do that very quickly with our software. After we calibrate the array, we can then move on to other parametric tests. In this case here, we're using modulation distortion on the VNA to show the BathChub curve, where we can see both the input and output response of the array. So in the yellow trace, we can see the input, which is coming from our VXG signal generator with a 1 gigahertz wide band signal at 29 gigahertz input frequency. We can see the output, which shows the nearly 60 dB of gain of the array, and then also the distortion products that can be represented here with the BathChub curve, showing the increase in EVM as we increase the output power of the array, and we can also see the compression beginning on the array. This is all done within the VNA software. For folks that like to look at constellation diagrams of that same EVM performance, we can see the input as well as the output of the array. So we can see the constellation diagram of this 16 QAM 1 gigahertz wide signal, and you can see the EVM at the higher output powers begins to degrade up to about 3%. But again, these tools are all part of our phased array test solution, which allows customers to evaluate their product very quickly with a single test solution. So a key aspect of the F9652 compact antenna test range is the frequency range it'll cover. This particular model covers from 6 to 110 gigahertz, but Keysight offers models going from 1 gigahertz to 220 gigahertz. This particular model has a quiet zone size of 40 centimeters, but we do offer quiet zone sizes up to 1.5 meters for larger devices. Please contact Keysight at keysight.com to find additional details about our solution.